Good morning, Algebra 2, and today we are doing this Ed puzzle and finishing up our notes on projectile motion. So make sure your table of content looks just like this. Add projectile motion to the next line. Pages 34 to 37 is where we're taking notes on. We did one problem on page 34. Let's make sure to continue doing that on page 34. I'm going to pause the video and you copy this down now. The first example we did in class was a ball thrown directly upwards from an initial height of 200 feet. If you do not have this example in your notes from yesterday, please take a second and make sure you have this example in your notes before we go over a couple more examples. Alright, so pages 34 to 35, make sure you're writing this all down. So Abigail tosses a coin off a bridge into the stream below. The distance in feet the coin is above the water is modeled by the following function. So our first step whenever we're doing these problems is we need to figure out what's happening in the problem by drawing ourselves a picture. So we know Abigail is on a bridge and she's tossing a coin off of the bridge. So we're going to take a second and we're going to sketch what is happening. So I'm going to draw my little bridge right here. Here is my bridge that Abigail is on. It's not the greatest bridge, but we got it. Here's some water. And we know that Abigail is standing on this bridge. And she is about to toss a coin over the bridge. So here's my coin. So I have Abigail that's tossing a coin off a bridge into the stream below. Okay, so we know whenever we toss, projectile motion makes a quadratic shape. So we know she's going to toss this coin up and down into the stream below. So we are going to use this diagram to help us answer these four questions. So make sure you're drawing your picture. We got Abigail on a bridge and she's tossing this coin into the water or the stream below. So how long is it going to take for the coin to reach its maximum height? So what's super important here is our keyword maximum. Now our picture is awesome to help us to figure out what's happening in the problem, but what we need to put our modeled equation of a quadratic into Desmos. So I'm going to open up Desmos and put in my quadratic, making sure to type in h of t equals negative 16 t squared plus 96t plus 112. Now one thing you'll notice is if I zoom out, my quadratic is super squished. So one thing I'm going to do is I'm going to click on my gear and change my what I can see. And I always go from negative 10 to 10. And this just gives me a better look at what this quadratic function is looking at. So I'm going to click on this and I see all of my magic points. So we have that y-intercept, which is the point where our coin starts. We're starting at 112 feet. We have our vertex and we have our intercepts down below where it crosses the x-intercept. So in part A, it says how long does it take for the coin to reach its maximum height? We have that keyword maximum. That keyword maximum refers to the vertex of our quadratic. This is the highest that coin will get, the maximum value. So we are all focused in on this vertex point, which is at the point 3, 256. Now, this is the maximum, but we want to know how long does it take for the coin to reach that height. So we need to know, okay, is 3 my height or is 256 my height? Well, if I look at my function, this is the function h of t, where h represents the height and t represents time. Since t is the variable inside of our function, that's our x-axis. So our x-axis and x values are all times. Our h or our y is all of our heights. So this coin reaches a maximum height of 256 feet after 3 seconds. So I know for part A, after 3 seconds, my coin reaches the maximum height. So if we wanted to go to our picture, right here is the point 3, 256. So this is the maximum height that coin is going to get on its entire trajectory. Which brings us to that next problem. What is the maximum height? Again, what's super important is we're on the lookout for these keywords. Maximum height. Because it's the maximum height we're looking for, that means we're looking for part of the vertex. So after 3 seconds, the maximum height of my coin is going to be 256 feet. Units are super important. So 256 feet is the maximum height of this coin that's being tossed. So our coin starts on the bridge, it gets thrown. After 3 seconds, it gets to its maximum, which is at 256, and then the coin is going to fall until our coin finally enters and hits the stream below. So part C asks us, how long will it take to hit the water? So we know after 3 seconds the coin hits its vertex and the highest. We want to know, when is it going to hit the water? Well, in order for this coin to be at the water, then the height of the coin would have to be 0. We need a 0 height. So that's key. We want our height to be at 0. We want our height to be at 0, which means we want to find a 0. So if I open up my Desmos, I have 2 zeros. I have one at -1, and I have one at 7. Now, one of these doesn't make sense. -1 doesn't make sense because we can't have a negative time. It doesn't make sense to say after -1 seconds, our coin hits the water. Okay, so this doesn't actually exist in our problem. So we start at 112, we throw. After 3 seconds, we hit the top, and it looks like after 7 seconds, we finally hit the water because we know the height of that coin after 7 seconds is 0. So how long will it take for the coin to hit the water? Well, it'll take 7 seconds. Okay, so this is the 0.70. So the coin is thrown. After 3 seconds, it reaches its maximum, 256. After 7 seconds, it's hit the water. We know that because the height is 0. Last problem we're going to do for this one is, when will the coin be 30 feet above the water? 30 feet above the water. Now, this isn't a special point on our graph. However, we can still find it. We want to know when the height, when will the coin be 30 feet? We were given the information 30 feet. So we want to know when is the height, 30 feet. Okay, the information that was given to us is, we know our y has to be equal to 30. Y has to be equal to 30. Okay, we want our y value to be 30. So if I go over to Desmos and I add that in, y equals 30, so 30 feet. We want to know, when is this coin at 30 feet? So we graph this line. Again, we get 2 points where our graphs intersect. One at -0.758 and one at 6.758. Now, one of these we can't use. We can't have negative times. So this is the only point that makes sense. So to get an idea of what happened, this graph shows this coin being thrown up. It hits its max, and it falls. At 6.758 seconds, it's 30 feet, and then it'll keep falling until it hits the water. So 6.758. 6.758. After about 6.7 seconds, our coin will reach 30 feet above the water. So, right about here, we finally hit that 30 feet. So that is our second problem. So again, pause the video. Make sure you have this entire thing copied down. Okay, you've copied this down. Here's the next one. Okay, so we have at a swim meet, Janet dives from a diving board that is 48 feet high. Her position above the water is represented by the equation h of t equals negative 16t squared plus 24t plus 48. We know t represents time in seconds and h of t represents height in feet. Again, we're going to start by drawing a picture of what's happening. So we're at a swim meet and she's diving from a diving board. So we have a diving board. We have Janet on top of that diving board, which means we have water below. And when we're dealing with projectile motion, we always know that it's going to be a quadratic, so she jumps up and down into that water. Okay? So we need to answer 3 seconds. After how many seconds does Janet enter the water? What is the greatest height Janet reaches? And how long will it take to reach the max height? So we have three things to figure out here. A, B, and C. So first, how many seconds does until Janet enters the water? So let's think about what's happening in this part A. In order for her to be hitting the water, she would hit right here. Would be when Janet enters the water. What is going to be the height of Janet when she hits that water? Well, when Janet hits that water, she has a height of 0. She has a height of 0. Okay, so let's go put this into our Desmos. H of t equals negative 16 t squared plus 24t plus 48. Again, I'm going to use this small little wrench and I'm going to adjust what my graph looks like. I'm going to change it from negative 5 to 5 just so I can see a little bit more, which it doesn't look like it adjusted, so let's do that one more time. Negative 5 to 5. So here's the quadratic of her diving. She's starting at 48 feet. She jumps up and down, 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 down until she finally hits the water. She hits the water when her height is 0. So we're looking for our zeros. After 2.63 seconds, Janet has finally hit the water. We know that because her height is 0. This other x-intercept is 0 as well, but remember, it doesn't make sense. She doesn't jump in negative 1.137 seconds. We don't have negative time. So our only possible answer is 2.6 about seconds. So for part A, 2.6 seconds. So after 2.6 seconds, Janet has reached a height of 0, which means that she has hit that water. So her entire dive is about 2.6 seconds long. Part B. What is the greatest height? Now we have that keyword, greatest height she reaches on her dive. When we see the word like maximum, greatest, highest, biggest, longest, those maximum values, that means we need to find the vertex. So we need Desmos to help us find this vertex of the dive. We want to know what's the highest point of the dive. So we go back to Desmos and we click on this highest point and we can see that the highest she gets is 57 feet, because remember, it is our y value that are our heights, the x values are all time. So after 0.75 seconds, she gets 57 feet above the water, feet high. That's the maximum she gets because this is the vertex. So for B, we have 57 feet. It is right here that she is 57 feet above the water. Okay, our next question asks us, how long will it take to reach the max height? We see that keyword max, which means we need to look at Desmos and look at our vertex. Vertex is the maximum. Now we're looking at how long does it take her to get to 57 feet? Well, it takes her 0.75 seconds. 0.75 seconds. After 0.75 seconds, Janet has reached the maximum height of her dive at 57 feet. Then she starts to fall. And it is after 2.6 seconds, her height is 0, which means she's entered the water. And that is the answer to our 3 parts. Okay, pause the video. Make sure you copy this entire example down. So here's the last one we're going to do. Jen and Chelsea build rockets from assembly kits and are going to launch them at the same time to see whose rocket flies higher. If Jen's rocket's height in feet can be described by the equation J of t, while Chelsea's is represented by C of t, we want to know who wins the rocket race. So what is the max height for both rockets? After how many seconds does each rocket land? And then to the nearest tenth of a second, what was the difference in time for the 2 different rockets to reach their respective heights? So we have two rockets being launched, and we know a rocket will go up and it'll fall down. We want to first know who wins the rocket race. What is the max height for both rockets? So we're going to need to put in both of our functions. We have J of t for Jen equals negative 16 t squared plus 180 t. So here's our first rocket, which is absolutely large. Our second one is C of t, and we're going to put them both in Desmos, equals negative 16 t squared plus 240 t. Okay, one thing, it's very hard for me to see this graph, so I'm going to go to my gear, and I'm going to change my x-axis to be from like negative 1 to 5, or let's do 10. Oop. Looks like we have to do just a little more. 15. Okay, so here are the graphs of my 2 rockets. We have Jen's in red, and we have Chelsea's in blue. I'm going to move this to the other side so we can answer our questions. So if I'm looking at this, who wins the rocket race? What is the max height for both rockets? We have a keyword, and that keyword is maximum. So I'm going to highlight that because I know that is super important. Max height. Okay, so for part A, if we're trying to find the maximum height of both rockets and see who's gone farther, this means we need to look at the vertex of both rockets. Okay, so if I go over here and again click on my graph, I can see Chelsea's went 900 feet and Jen's went 506 feet. So Jen's is in red, so Jen, her rocket went 506.25 feet. And in blue, Chelsea's I don't really know how to spell Chelsea, but hers went 900 feet. Okay? So again, because this is a maximum height, we are looking for y values, and we're looking at the vertex because this shows the highest our rocket will be. And in this case, if we wanted to know who the winner was, the winner would have been Chelsea, because hers went 900 feet, whereas Jen's only went 506 feet. Okay, part B. After how many seconds does each rocket land? So in order for the rocket to land, its height has to be 0. In order for it to land, the height has to equal 0. Okay, so if we go back over to Desmos, we want to know when, let's look at Jen. Jen is the red. When this rocket starts on the ground at 0 seconds, it goes up, 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 up. After 5.6 seconds, it's 506 feet in the air. And then it begins to fall, 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 fall. And it is, when the height is 0, 11.25 seconds have gone by. We're looking for the zeros. We want the height to be 0 because since the rocket is landing, it's on the ground. So after 11.25 seconds, so for Jen, her rocket was in the air for 11.25 seconds. If we go look at Chelsea, we're going to click on our blue graph. She starts at 0, goes all the way up to 900 feet, and then begins to fall. She doesn't hit the ground until 15 seconds after the launch. So Chelsea, she was in the air for 15 seconds. Okay, and this, we know to pick this point because how many seconds does each rocket land? So we know that we're looking at x values because we're talking about seconds. And in order for it to land, it has to have a height of 0. A height of 0. Okay, we have one more question to answer. To the nearest tenth of a second, what was the difference in time for the two rockets to reach their height? So we're looking at what was the difference in time for the two different rockets to reach their max heights. So since we're now talking again about their max heights, for part C, we're focused on the vertex of the quadratic. The vertex. So if I go back and look at my vertex, I have 900 and 506 like we found in part A, but we're looking at the times. So Jen's rocket, which is red, took 5.625 seconds to reach that max height. Whereas Chelsea took 7.5 seconds to reach her maximum height. Now, these are how long it took for both of them to reach their max height. This problem wants us to find, to the nearest seconds, what is the difference in time. Difference means we're going to subtract these. So to find the difference in time, we would take our 7.5 minus 5.625. 7.5 minus 5.625, and if I do that in my calculator, 7.5 minus 5.625, that's 1.875. 1.875 was the difference in time. So it took Chelsea's rocket an extra almost 2 seconds to reach that maximum height. And that is the answer to all of our parts. All of this should be in your notes. All of this should be in your notes. Please make sure to get everything down in your notes. You should have 4 examples on pages 34 and 35. Have a great day.